Hey everybody, welcome back to General Science, and today we're going to be talking about the carbon cycle. What? Show anyway. There we go. Yeah, it's fine. Alright, we're talking about the carbon cycle. So, the carbon cycle, which we alluded to in the last video, which was about the water cycle, is really important, especially when it comes to climate change. So we're going to be talking about that today as part of our environmental science talks. Wow, really? Hold on a second. We're going to do some fixing here. Reload. What? Okay, it looks fine. All right, so what is the carbon cycle? Well, the carbon cycle describes the pathways that carbon moves throughout the environment. So how is it that carbon atoms flow and store in the environment? The flow of carbon, mostly by following CO2, has helped scientists better understand how CO2 concentrations can affect the climate, which is a big part of global warming and the climate crisis that is coming more and more clear that's coming. So here's an overview of the cycle. It shows how carbon that begins buried underground is brought to the surface, vaporized, and then added to the atmosphere, and then may be reabsorbed by forests or agriculture or the oceans, and the cycle begins again. So as we said, right, carbon starts down here, it comes out, comes down, and goes in this cycle. Now, we start off with what we call buried carbon, which is carbon that's been buried deep underground in the form of fossils, natural gas, and oil, which took millennia for that to happen. Right? Oil is a highly compressed organic matter, which is made of carbon, and it becomes a liquid. Natural gas is created in the Earth's crust and is primarily made up of carbon, and fossils are hardened carbon minerals. So all of these things, right, are being stored underground over the course of Earth's existence. Now, due to our industrial economy, humans have now been scouring the Earth for these reserves of carbon because we use them to fuel our machines. So we drill for oil and natural gas, and we've been quickly deteriorating the natural stores of carbon on this planet. And since it takes thousands of years to rebuild those stores, we've begun to realize, right, that we might run out of these resources that we are depending on, but also all of that carbon has now been pushed into the atmosphere. So instead of being underneath the Earth, stored safely away, it's been pushed into other parts of the cycle. So before the Industrial Revolution, the amount of carbon entering the atmosphere was relatively stable, as you can see in this line here, right? This is the amount of carbon that's being put into the atmosphere. And then right around here, which is when the Industrial Revolution begins, it starts to climb. And then when we hit the world wars, then it begins to shoot up drastically, especially because the Industrial Revolution had spread everywhere. So burning fossil fuels has greatly increased this concentration, and it's been rapid, almost at certain points, not linear. My words escape me today, but it's been a very high increase. And the pink line represents atmospheric carbon. So this has been a really stable amount over time, and now it's really ramping up in the last 20, 30 years. Now, this affects what's called the greenhouse effect. Carbon dioxide is one of the main products of burning these carbon reserves, and it's a greenhouse gas, which means that CO2 traps heat on the planet. It's part of our atmosphere, and it is what keeps our planet warm. So that means more heat is being trapped around the planet, and our planet is becoming more and more of a greenhouse. As atmospheric carbon dioxide rises, the more heat is going to be trapped in the Earth, and this is going to cause lots of issues. It's difficult to capture the CO2 in the atmosphere, meaning that CO2 that's there is going to be there for a while. So what can we do? How are we going to reabsorb that carbon? Well, one of the ways carbon is generally reabsorbed is through forests, rainforests, and jungles. They are the main things that reabsorb carbon from the atmosphere. Plant life uses CO2 as fuel to to create energy and photosynthesis. However, the Earth and its plant life can only absorb a fixed amount based on how much flora there is. And we've been burning a lot of or taking down a lot of our flora. We've been deforesting, cutting down rainforests, destroying jungles. And so that fixed amount is getting smaller. Human agriculture can also absorb carbon dioxide, but just like other plants, the food we grow also needs this carbon dioxide to create energy and sustain itself. However, it's limited. We don't have, we can't cover the entire world in agriculture, and even then, it's only going to absorb so much carbon dioxide. So it's a very limited amount. The ocean can also absorb carbon and store it, and seawater does that by absorbing carbon dioxide from the atmosphere and making what's called carbonic acid and bicarbonate ions. And this happens all the time. However, the ocean can only do so much of this. There's only a feasible amount that it can actually absorb before the ocean becomes acidic or super acidic. So the final stage of the cycle would normally be for the carbon to be reburied in the earth, and this process can take millennia to do. The creation of natural gas, oil, and fossils takes time and is also limited. So before the Industrial Revolution kind of put this into overdrive, this system worked really well. There was no major shocks to the system, and the limits of the atmosphere and ocean for carbon was fine. Okay. Now, though, the cycle has become unbalanced. Mining for fossil fuels has exhausted the supply of fossil fuels that we had in the earth. All of these things that took thousands and thousands of years to make have been used up in a relatively short amount of time, only 200 to 300 years. The ocean has also now become has reached its carbon capacity. The ocean is always a little bit acidic because it absorbs carbon dioxide. However, with the steep climb of carbon dioxide in the atmosphere, the oceans have become too acidic. So oceanic life like fish, coral, and other life have begun to die out because it is just too acidic in the water. And of course, there's too much carbon dioxide in the atmosphere. If you look at this graph here, this is global temperature and the carbon dioxide concentration. So if you look at this graph here, starts at the Industrial Revolution. This is the concentration of CO2 in the atmosphere. As you can see, it's risen steadily and then exponentially, the word I was looking for earlier, starting in around the 1960s and 70s. The average temperature during this time, which is set by these lines here, has steadily increased. And every year since 2015, the Earth has gotten hotter and hotter and hotter. These global temperatures are going to be causing big issues on our planet. Yes, it's humans, which basically means that because the things our planet is getting so hot, glaciers, ocean currents, and other things are changing. The currents are what keep our climate steady, and if the currents are knocked out of whack, it's going to affect how our planet's weather is. And of course, it's also going to raise sea levels as the glaciers melt. These issues have already started to happen in 2022. And what caused this? It was us. We did this. We're the ones doing this stuff. As you can see, right? We're the ones destroying our planet. It's kind of our fault. Now, there are also solutions to every problem, right? Anything that we can do to destroy the Earth, we can also help to fix it, but we need to take drastic and dramatic action at this point. Some possible solutions are carbon capturing, which is something that scientists have been working on pretty hard, which is trying to capture CO2 and pull it out of the atmosphere. And some of these methods are already being tried in factory smokestacks. Large-scale carbon capturing is still in development, so we're not quite there yet. We're also trying to change to new fuel types that aren't releasing large amounts of CO2. These new energy types are nuclear energy, which produces lots of energy, but also has some cons and radioactive byproducts. Solar energy, which is clean but a little inefficient still. Wind energy, but we need space and we need to have constant sources of wind. Hydroelectric, which is pretty clean, but we have to mess with the natural flow of water. And then geothermal, which is clean as well, but there's not a lot of places to actually do this. It involves tapping into geothermal events, and there's just not an abundance of these, which is part of the issue. Now, all of these things combined could definitely stem the tide. Hydroelectric power is powering some countries completely. There are other countries that have powered themselves completely on wind and solar energy. So it is possible for us to make these changes, but we have to do it sooner rather than later. We've also thought about potentially just reburying the carbon. We just solidify it into bricks and then rebury it deep underground. The carbon would be stored underground, and it would be able to stop the CO2 concentrations from getting too high in the atmosphere. The things that are issues with this is, one, how are we going to get that carbon into solid form and then put it underground? And where would we even bury it? We would have to find a place to put it, and that would mean disturbing the ground even more. So this is obviously an issue moving forward, and it's something that the world governments is starting to finally actually take some action on. Is it enough? A lot of climate activists and scientists say it is not, but it is a step in the right direction. Hopefully we can mitigate the biggest parts of the disasters before they get even worse. Thank you guys so much for watching this episode of General Science, talking about the carbon cycle and the climate crisis. We'll only have 2 more episodes left after this one, where we talk about the tragedy of the commons and climate change in general. Thank you guys for watching, and I can't wait to share more science with you next time. Thank you.